Hey everyone, today I'm going to show you how to multiply a binomial and a trinomial together. So we've multiplied all types of polynomials so far, and now we're going to be getting a little bit trickier just because what we're multiplying is getting a little bit bigger and there's going to be more things that we need to multiply. So we've looked at previous this binomial by binomial, so two terms by two terms like this. And we used something called the FOIL method where we took the first terms, then the outside terms, and then the inside terms, and then the last terms. But can't really do that with the multiplying by a trinomial because if we look at first, good, outside, okay, but then when we get to the inside, there's multiple things on the inside. So we're gonna use the distributive property. It can kind of get a little messy. But then I'm also going to show you the box method, which maybe isn't as messy, might be more clear for you. It's going to be, again, your choice and what makes sense for you. So just like when we were taking a monomial and we were multiplying, we want to make sure that every term hits the other polynomial, meaning like this 3 needs to be multiplied by this, by the 3x, by the -2, but then I got to do the same thing for the x as well. So I'm going to use two different colors to hopefully color code it. Maybe it'll make more sense. So I'm going to start with the first term in this first polynomial, and I'm going to distribute the x to every term that is in the other polynomial. So I'm going to start with taking the x and I'm going to distribute it to 4x. So that means we're going to have x times 4x squared. Then I'm going to take the x and I'm going to distribute it to the 3x. So we'll have x times 3x. And then we're going to take the x and distribute it to the last term. So we'll have x times -2. Don't forget the negative sign. Now, we still have a whole other term that we also need to distribute. So now I'm going to come in with another color. And so now we're going to focus on the 3. So the x has been multiplied by all of those. We've hit them all. Now I got to do the same thing with the 3. So I'm going to take 3 and I'm going to multiply that by the first term, the second polynomial, which is 4x squared. Then we're going to take 3 and multiply that by 3x. So we get 3 times 3x. And then 3 all the way to this last guy down here. And it's going to be 3 times, again, don't forget it's -2. So now we've created 6 separate multiplication questions, essentially. And if you should have 6 because here's why. I have 2 terms here, I have 3 terms here. So 2 times 3 is 6, meaning I should have 6 multiplication problems, and I do. So now this next step is to simplify this, to start to clean this up and make it look a little bit neater. So attacking each of these 6 questions, so we have x times 4x squared. Remember there's a 1 that's right there. So it is 4. Remember there's another 1 in that exponent. So it's going to be 4x to the 3rd power because 1 plus 2 makes 3. Plus, again, there's an invisible 1 here, so 1 times 3 is 3. And again, an invisible 1, an invisible 1. So it's going to be x to the first times x to the first, which is x to the second, because 1 plus 1 is 2. Moving to this third problem, x, again, there's an invisible 1. 1x times -2, that is going to be a -2, because a positive and a negative always makes a negative when multiplying. -2x. Moving into these green problems. 3 times 4x squared, so 3 times 4 is 12, and it's just going to be 12x squared. And then we have 3 times 3x, again 3 times 3 is 9, and then it's just 9x. And then finally we have, we're down here, 3 times -2, so positive and a negative make a negative product, which is going to be -6. Still a lot of stuff going on there. There are 6 terms. I need to see if I can clean this up. So I have x cubed as this first term. So I'm going to see, do I have any other x to the 3rd power? We do not. So it is going to stand alone. I see, I have 3x squared. Do I have anything else with x squared? And we do. So we have 3x squared here, and I have 12x squared there, which means they can be combined together. 3 plus 12, so the 3 plus the 12 is going to be 15x squared. I have negative 2x. Do I have any terms that with an x? Down here I do, so I'm going to, I don't know, I'm going to box this and then box this. So we have negative 2, positive 9. So if I combine those together, unlike signs, so I take their difference, so the difference between 2 and 9 is 7, and because this has the 9 is the bigger absolute value and it is positive, it is going to be a positive 7. If you are not sure, you could always put in your calculator negative 2 plus 9, and it will also say positive 7, but positive 7x. And then finally, we have minus 6 at the end. Notice with my exponents here, with these two, it stayed the same, and here it stayed the same because we're adding, not multiplying, so we don't do anything to the variable and the exponents. And that is the final version of that. That can take a lot of time to do, and there's a good chance that you could possibly make a mistake. But you could also multiply by using the box method. So the box method might be your friend when multiplying larger polynomials as so. So I'm going to stick with the same problem, and I want to see, will we get the same answer if we use the box method? Spoiler alert, we will. So when we're using the box method, we need to make sure that we create a box that mimics what we have here. So we need a box that is 2 by 3, because there's 2 terms and there's 3 terms. So I am going to make my box. So first step, make a rectangle. So it's got to be 2, so I'm going to split it in half, make 2 rows, and it's got to be by 3 columns because this has 3 terms. So I'm going to 1, 2. Yes, that didn't really make it that even, but that's okay. So I'm going to put x in 3 down here, so x, and I'm going to put 3, and then I'm going to put 4x squared. I'm going to put the 3x here, and I'm going to put the minus 2 here. And again, remember, when we're using the box method, we are multiplying. Think of it like old school when you were in elementary school, the multiplication tables when you were learning how to multiply. So I'm going to start with 4x squared. I'm going to take 4x squared and multiply it by x, and that is going to give me 4x to the 3rd power. Because remember, the shy invisible 1 that's here, and that's there too. So 4 times 1 is 4, x squared times x to the 1st power is x cubed. And then I'm going to take 4x squared and multiply it by 3, so I'm going to get 12, and then x to the 2nd power. Now I'm going to move over to 3x. So 3x times 1x to the 1st power, so 3 times 1 is 3, x, remember there's an invisible 1 there, x to the 1st power times x to the 1st power is going to be x to the 2nd power, add those exponents, and then 3x to the 1st power times just 3, 3 times 3 is 9, and then it's just going to be x. And then finally we have negative 2, so negative 2 times 1x to the 1st power, negative 2 times 1 is negative 2, and then just 2 with the x at the end, and then negative 2 times 3, so negative 2 times 3 is going to meet here, and that's going to be negative 6. You're seeing very similar terms to what we had up here. So now I want to see, again, kind of if you remember, if you watch the binomial box method one, you notice how we had like the diagonals had the like terms. So I have the same idea here. I have these two are like terms. They both have x squared. And then if you look here, these are like terms because they both have a single x. So when I'm writing out my answer, I'm going to start here in this corner here, the upper left. So it's 4x to the 3rd power. And then I can combine these together. They're both positive, so I'm just going to add the coefficients. So 12 and 3 make 15. And then it's x squared. And then I'm going to combine these. Negative 2, positive 9 is going to make a positive 7. It's going to be a positive 7x. And then at the end, we have negative 6. And if I remember correctly, we got the same answer. So the same answer, maybe a little bit quicker down here with the box method. There is not, it looks like it's a lot less work. But there it is. I'm going to go ahead and just make another video maybe showing another example. If you still need this cleared up and you're still unsure, I will make another video that you can go to and just watch just to see another example. But I hope this helped. Again, if you get stuck, watch the other video that I'm going to have, or Google it and see if you can find up your own video. Okay? Hope this helped.